Ladies and gentlemen, welcome back for another adventure in miscellaneous to-dos around the house. In this particular episode, we're not going to be working on cars. We're going to be working on installing a VHF UHF beam in the attic. And I want the beam to be able to rotate. Now, so this is going to be my rotator, and we need some way to mount the rotor, and we're going to use this piece of wood so that I can mount it. And what we'll do is we'll drill some holes so that the rotor will look something like that, and then we'll cut it down here so that we can then screw this board into the side of a ceiling joist to have the rotor oriented so it's vertical. And then we will of course put pipe inside the rotor and put an antenna on top of the pipe. Will probably be PVC piping. Because it's going to be a small antenna, it's not going to be a big one. And I'll show you the assembly of the antenna as well, because it has arrived. Each Christmas I buy something for myself, a little treat for the previous year's hard work. And this year's my Christmas gift to myself was this 2 meter 440 log periodic beam from Elk Antennas. So we'll be assembling this, and this is the antenna that's going to ultimately wind up in the attic. But I'm going to show you all the steps that I go through to make this all happen. The objective ultimately is to be able to work the most popular, I guess, repeaters in the area, and popular is a bit of a term because just like everywhere else, or most everywhere else in the country, repeaters are not used with the kind of frequency that they used to be used. Yeah, I suppose that's because of the digital modes. But there is a local club that is trying to get people back on the air on their repeaters. So in any event, that's ultimately the goal. So we're going to first prepare this board for the beam, the rotor, and then we're going to put the rotor together and figure out exactly where it's going to go in the attic. I expect that the most challenging part of this whole thing is going to be figuring out how to route both the rotor cable and the coax into my ham shack. Because it doesn't look like there is easy access to that area of the attic space over my shack. So we'll cross that bridge when we get to it. In the meantime, let's prepare. So I'm going to do a little bit of work on this board to get it ready, and we'll show you that. And so there'll probably be a lot of cutting and clipping on this video instead of my usual as long as possible continuous videoing, simply because of the number of steps involved here, and this will probably be over several days, maybe even longer. And I do that because it's easier to edit that way, and I don't have the time to spend on high production value, quality, whatever, and doing all kinds of cute and fancy things with video. So be that as it may, I'm going to adjourn over to the chop saw to do some cutting. We'll see you in a minute. Okay, so I'm just going to cut a length of wood, and we'll use hearing protection because the saw makes a lot of noise, and we will also use eye protection just because I'm dumb but not stupid. And we're going to square up the end of the board, and then we'll just cut a length. It doesn't have to be precise because obviously It's going in the attic, nobody's going to see it. It's all about the antenna performance, so we'll get a nice square cut. It's about 1 inch. Make sure this thing is set to 0. It is. Put on my hearing protection. Okay, so now I've got my nice square edge. Even though I don't really need it, I don't know, you know, not even sure why I'm doing it, but what the hell. And this should give me roughly 1 foot. Now the 2 ends are square, so we've got a board to work with. So let's go back to the workbench. Okay, so the next step is to drill some holes. We have a 1/4 inch, I believe, yeah, 1/4 inch drill bit. And we're going to drill 4 holes. To mount this rotor. And it doesn't, again, it doesn't need really to be super precise. I do want it as straight as reasonably possible so that I don't have to muck around too much with it when I mount it, so that it's not the leaning tower of antenna. But we're gonna just use the rotor to indicate where to drill the holes, and let's try this first. Just a couple of taps to mark the board. If that doesn't work, we'll use pencil. And you can't see the marks, but I can, so I think we're good. So just make sure that I'm still in the camera, and I am. So might as well keep those safety glasses on, can't hurt. I think that is getting a little dull. That 4th mark isn't quite good enough. So let's just orient this. There. So Okay, good enough. I'm missing a couple of washers, so I think I'll hunt around for 2 more. I'm sure that I have them somewhere. But that's the idea. So the bottom part of this will screw into a joist, and that'll be the rotor assembly up in the attic. Still to be done. This used to be up in the attic in my old house, and in the expediency of removing everything from the old house and moving, I simply cut the cable. So we'll want to reconnect the rotor to the control box and make sure that the rotor is oriented towards north. It really can be oriented in any direction that you want, but the northern orientation will mean that when I put the antenna on, all I need is a compass to point the to adjust the mast in the antenna so that it's pointing north, and that will automatically mean that the rotor is synchronized. So off camera I'm going to find some more washers to finish this up, but that's the first step, is building the mounting bracket, so to speak. So that's covered, and on to the next step, which will be the next, I think the next step will be orienting the rotor to due north, reconnecting it and all that fun stuff. So until then. All right, we're back. So I'm going to hook up the controller to the rotor to make sure that the rotor is oriented to the north. And in order to do that, I have to connect it with this rotor cable. I don't know if you can see that, but on this 3-wire rotor cable, it looks like one end has a different color to it, like it's tinned. Here's the other end. So to my eye, that looks like a silver color. That looks like a silver color as opposed to the copper color. So I'm assuming that that is what we'll call number 1, but I'm going to verify that using this ohm meter, because obviously we don't want to miswire our rotor. And as you can see, very low ohms, 1.8 ohms, so that looks correct. Just to show you, that's weird. Oh, it's mega ohms, yeah, so that's an open, and that's an open. Okay, so for when I have to put this back together later, just to be safe, I am going to use some liquid tape to mark that end, or that that wire. So I know what number 1 is. Could use tape as opposed to liquid tape, a colored tape of some kind, or even wire cable tape, or wire cable markers, I should say, whatever you've got handy. So let's wire this up. Of course, this is just temporary. so that I can orient the rotor before I make the attempt to install it. Okay. This is my liquid tape one. So that's number one. And middle is going to be number two, the middle wire, I should say. Flip side. And by the way, this controller is not plugged in yet. That should be good enough. Okay, so let's plug our Radio Shack controller in. And it is not currently oriented to the north, to the southwest, which is where the main repeater at my old house was located. Okay, so now as far as the controller and the rotor are concerned, the rotor is pointing north. So when I install the antenna, I just need a compass so that the antenna is also pointing to the north, and everything will be automatically synced up. So this is now good to go for me to climb up in the attic, find a place to put the rotor, mount it, and then get the antenna together, and probably it will be like 1.5 PVC for mounting the antenna. So those are the next steps. Not sure if that'll be today or tomorrow or what have you, but I will certainly bring you guys along for the trip. So until we meet again, a few seconds for you, and God knows how long for me. See ya, bye. All right. Jumping around a little bit because I've realized that I can't really place the rotor until I know what I'm dealing with from the standpoint of how much room this antenna needs in my attic. So I need to put the antenna together. Half-inch PVC. Let's not assume. Paid. Thanks for telling me that. Any suggestions? The antenna points towards the end having the coaxial connector. When attaching the coax cable to the antenna, dress the cable to extend straight away from the connector for at least 8 inches before starting a gradual curve to have the cable meet the supporting mast about 20 inches for 440, 30 inches for both 2 meter and 220. This is 2 meters and 440. This orientation is not allowed. If this orientation is not allowed, severe SWR degradation will occur, and the full superior superior performance of our antennas will not be achieved. 2 different techniques are shown in the photos below. The rule is no conductive material in parallel with the elements. Slide along the end of the boom to observe parallelism with the elements. If the elements are not parallel, bend the screws to make them parallel. Although slight non-parallelism is just cosmetic, it does not affect performance. If desired, the PVC fittings may be glued in place to prevent the antenna from changing position in windy conditions. Not a concern for me. Remember, if you glue the fittings, you will not be able to change the polarity. Some users have drilled holes at 90 degrees to allow for cotter pins. Yeah, okay. Remember to seal the front and rear edges of the knurled nut of the coax cable. We recommend coating the white PVC support fittings with opaque pigmented acrylic lacquer. Krylon has a type specially formulated to adhere to plastic called Fusion to prevent ultraviolet light embrittlement. If the antenna is to be used in areas subject to long periods of rain, the antenna boom may be similarly coated. It's going to be under the roof, so that shouldn't be an issue. So it looks like all I have to do is connect the elements. And they're color coded. And I'm just going to go by shades here because I can't see red and I can't see green. So I'll bet you that's green. And this is blank. And red. Which my guess is this is red. Goes like that. So if this is the pointy business end, the direction, if you will, that means there's one. There's two. I was actually expecting these elements to be on a single boom, not a double boom like this. So that's kind of different and interesting. I suppose that's part of the log periodic design. And there's of course also matching tape, if you can see it here, here, here. So far so good. And Okay, so that looks like that's all there is for. Let's turn this over. These PVC mounts are that accepts a 1-inch tube. It says here on the side of the PVC, so will 1-inch do it? Or should I go up to 1.5 inch with a reducer? We can try 1-inch. PVC isn't that expensive. Okay, so the antenna assembly is finished. Writing elements parallel. They look okay. I'm curious how long this boom is. Since the trusses in my attic are 16 inches on center, 24 inches. So it's not going to make it to the apex of the roof and still have the full 360-degree turning radius. I don't think anyway. Well, we'll take it up into the attic and we'll see. Okay, so I need to go up in the attic and reconnoiter. And after I'm done reconnoitering, I will share with you what I found. So we may meet next up in the attic. See you then. Okay, we're up in the attic and we are reconnoitering where we might be able to put the antenna, and all of this ducting is making it a chore since there are no open spaces. Now that in there, that might be an open space large enough, but it's on the other side of this big trunk of ducting. I don't think there's, well, maybe. This open space right here, as such as it is, but there's this foil-lined duct that runs right next to it. I don't know if that's going to interfere with the performance of the antenna or not. We're just going to have to find out. The only other place would be right in here is a void, although the antenna will be close to the joists rather than up towards the ceiling. So I would say that area in there would be plan B, and this area right here would be plan A. So that means that the rotor will go along this, somewhere along this joist, and then we'll see how it all works. The object is to be able to rotate this thing 360 degrees. Now, elevation is important. The higher up I can get this antenna, the better. Unfortunately, I can't get it up at the apex of the roof because of all of the ducting. We'll have to see. Looking up in that void there, above the duct work, that might help. That might work, I mean. Not sure. We'll have to experiment, and I'm going to need both hands for that, so I'll show you what the result of my findings are after I've figured that out. I'd prefer to have the antenna in the clear, so to speak. Maybe this void in here near the rafters is the better of the two strategies, or the three. Maybe this is the third. Maybe I'll start with this one and work my way from there. And the other challenge that we're going to have is that over there in that corner where the flashlight is pointing in that general direction is where the coax needs to run to get to my shack. And I have a feeling that that's going to be the bitch part. So let me start, and we'll see how far I get, and I'll let you know. So we'll be back.